Integration by Parts by Amanda Canny and Sam Price. This is what we're going to do when substitution does not help. We will use our formula, integral of u dv equals uv minus the integral of v du. To go about this, we're going to start with step 1, which is pick a u, which is determined by what is easiest to derive, the least complicated option.
Our next step is to pick a dv, determined by what is easiest to integrate, the most complicated option.
Step 3, derive the u and integrate the dv, which will give you du and v.
Plug each into the equation accordingly.
You will be left with a reduction formula, which will make integrating simpler. Integrate.
Before you assume you're finished, distribute and GCF factor. Okay, let's begin with our first example problem, the integral of 3x squared times e to the 3x dx. First, because of the formula we have to conform to, we must identify those variables in the problem, u, du, v, and dv. We pick u to be 3x squared because it is the easiest to factor in the problem to derive. The derivative of 3x squared, or du, is 6x dx. Next, we need to identify dv so we can get v. We pick e to the 3x dx as dv, and when you integrate that, you get v, which is 1/3 e to the 3x. Plug your newly identified variables into the equation. Simplify, combine like terms, etc. Bring your coefficient outside the integral sign. You can't leave any integral symbol, so we have to integrate by parts again. We have to do what we just did, finding u, du, dv, and v within the integral of e to the 3x x dx. The new problem you'll get will look like this, because we plugged everything from the integral of e to the 3x dx into the original formula we've been using. X is picked as u, and 1 dx, or just dx, is picked to be the du. dv is e to the 3x dx, and v is 1/3 e to the 3x. Plug that all in after the 2, and we have 1/3 x e to the 3x minus the integral of 1/3 e to the 3x dx. Again, we can't leave integrals, so we'll have to integrate 1/3 e to the 3x dx. Luckily, we can integrate this regularly. Take out the constant and put it outside the integral sign like we did with the 2 earlier. Integrate e to the 3x dx, which is 1/3 e to the 3x, and 1/3 e to the 3x times 1/3 gives you 1/9 e to the 3x plus c. Do not forget the plus c. Now, plug the 1/9 e to the 3x plus c into what we were left with at step 5, replacing the integral of 1/3 e to the 3x dx. Distribute the -2 to 1/3 x e to the 3x and the 1/9 e to the 3x plus c. That gives you x squared e to the 3x minus 2/3 x plus 2/9 e to the 3x plus c. And last but not least, simplify, factor out, and remember plus c.
So now we have our next example problem, which is the integral of x times the ln of x squared dx. Once again, we will be using our formula to solve it. We have to identify u to get du. U is ln of x squared, making du 2 over x.
Say ln of x right now.
Ln of x. And dv is x dx, making v x squared over 2. Plug u, du, v, and dv into the formula, and you get ln of x squared times x squared over 2 minus the integral of x squared over 2 times 2 over x times the ln of x dx. Now, we see that we still have an integral sign in there, so we have to integrate that integral x squared over 2 times 2 over x ln of x dx using the formula. Identify u, which is ln of x, making du 1 over x, and dv, which is x, making v equals x squared over 2. Put those in the formula and get x squared times the ln of x squared minus the ln of x times x squared over 2 minus the integral of x squared over 2x. Again, we still see an integral symbol, so we have to integrate. The good news is that it's simple enough to just integrate using basic rules. So that becomes the